In this video, I will be guiding you through various different submodules involved in a hemodialysis mission. So, if it is a question asked in the exam, you should be in a position to write all these details that I'm briefly elaborating. In detail, you should write. While I will briefly elaborate what are the different things in a hemodialysis mission. Okay. So hemodialysis machine is used for production of warm dialysate, which is then circulated through an external dialysate assembly. It also controls the cycling of blood from the patient through artificial kidney and back to the patient. So why warm dialysate? To maintain the body temperature. The hemodialysis machine performs five basic functions. It mixes the dialysate, monitors the dialysate, pumps the blood, and controls the administration of anticoagulants. So anticoagulants are basically to avoid the coagulation or thickening of the blood or clotting of the blood. Monitors the blood for presence of air and drip chamber pressure. Also monitors the ultrafiltration rate. Okay. So this is the if you see in Kanpur your book, this is how a patient will be sitting, and through fistula in the venous area, it will be the bed will be taken, and it will be circulated through the dialysis machine. After purification, it comes back to the person. For this, there is the certain important submodules needed. One is proportionating pump. So mixing large amounts of dialysate dry chemicals at the time of consuming the because they cannot be kept mixed, it will lose its value. So they are these dry chemicals are mixed at the time of requirement, and they are pumped into the external dialysate membrane. Okay, towards the external dialysate membrane in the dialysis machine. Okay, so it will be having so blood from the patient. The blood from the patient is heparin is the anticoagulant in future, so it doesn't clot, and it goes to the dialysate dialyzer, where there is a membrane separating the dialysate and the blood. And once the after ultrafiltration happens, the blood is what happens is the blood is removed and it goes to the patient with measuring the venous blood pressure. While here the pressure blood pure water and concentrate of the chemicals are mixed, and the flow of dialysate is controlled with different pressure gauge for dialysate pump, pressure gauge for dialysate pressure to monitor dialysate pressure, to monitor the flow of dialysate into the chambers, to and for that purpose, okay, for pumping the you have a pump for dialysate, and you have a conductivity cell that will measure the electrical conductivity of the dialysate before and after the purifications. And there is a proportionating pump. So this is the pump that is going to pump your concentrate and pure water. These are dry chemical concentrate, they mix the pump and they are pumped into the conductivity cell for measurement of electrical conductivity. And before that, there is an heater that measures the temperature for producing a warm dialysate, and then it goes to conductivity cell for electrical measurement of the conductivity. And once it goes here, then it goes through the dialysis chamber. After purification, it comes here through the other chamber, and here it's checked for blood leak. So blood leak should not be there. As I told you, the performance is depending on residual blood volume and priming volume in previous videos. Dialysate pressure is also maintained, and pumps out the waste from the waste or used dialysate out of the system. Okay. So temperature control measurement, that will tell you that it should have a warm, and this is the different resistors, capacitors, and this is an full rectifier that will be controlling your system. So if it goes beyond a system, there is a thermostat kind of an arrangement that will switch off the this thing, and if it is going below, it will turn on the heater and so on. Okay, so this is one kind of an arrangement. And conductivity measurement is basically to understand what happens to the dialysate kind of before dialysis, and what happens to the conductivity of the electrical conductivity of the particles in the so if there are more particles in the fluid, the electrical conductivity changes when there is lesser particle in the dialysate membrane. Okay, so this is done by a thermistor. Okay, the composition of dialysate is depends on sodium, potassium, calcium, magnesium, acetate. So these are the composition of dialysate and their equivalent concentrations. So their concentrations affect the electrical conductivity. If there is a more, there is a different electrical conductivity. If there is a less, there is a different electrical conductivity. And dialysate pressure control system is mainly to understand that dialysate is pumped at a specific pressure, so that ultrafiltration is achieved properly. Okay, and venous pressure measurement is normally measured with the bubble trap, and a length of tubes connect plastic housing to which a stained gauze transducer is attached, and the floor of the point of connection to the blood line produces a small j pressure reading. Maximum accuracy, the sensor connection should be maintained at the same attitude. So this is measured at the venous side of this. And blood leak detector, what it does is, in dialysis machine, is a thin membrane separates the patient's blood from the dialysate, and normally the pressure on the blood side of the membrane is maintained at a much higher level than the pressure on the dialysate side. This is necessary to minimize the time required to the dialysis procedure. Besides, in order to reduce the total time required for the dialysis, membrane area is made large. Okay, so pressure is increased, area is large. Therefore, these two conditions, high pressure differential across the large fragile membrane, may result in the leakage of blood. In fact, even a relatively small tear in the membrane can result in the blood leak. So there is a detector that will basically avoid the blood leak. Okay, so membrane leak detector basically examines the light absorption of dialysate. So it has a photo system that will provide a light on the post dialysate membrane. Once this light has at the 516 nanometer, and absorption, and it is absorbed by a detector. So if there is a blood, the absorptions are different for peak spectral emissions, or to speak, absorptions are different for blood and for different solution. So it can tell you whether blood is available in the other side of the dialysate or not. Okay, so chopper, LED driver, transducer, signal amplification, absolute value amplification, envelope, comparator, and alarms. So alarm, when the value is above a specific level, there will be an alarm. So ultra filtrate monitor is used to monitor the amount of fluid removed from the patient, and in conjunction with the negative pressure to control the rate which is removed. So as I told you in the previous sections, the blood side is higher, kept at higher pressure, while the dialysate side at lower pressure to monitor to achieve ultrafiltration. So in order to maintain this, there is a specific system that is doing the purpose with CPU, with ADCs and stuff. So what are the other sensors that are available in this dialysate system? Okay, the other sensors, and if you see, this is the block of monitoring. So there is a load cell for measuring the pressure, and there are certain amplifiers that is basically taking the input, and from the both from the dialysate side as well as from the blood side, and gives an voltage to frequency converter, and gives A to D analog signal to convert, and gives to the computer for processing. Okay, so this is ultra filtrate monitor. There are also other sensors such as flow meters, for as you seen in the block diagram, effluent pump, so for removing the effluent out of the system, the blood pump for pumping the blood. Usually the flow rate is 50 to 350 ml per minute, and valves to control the movements, no, they are predefinedly set. Bubble trap, as we saw, so bubble trap, you would have read in the venous pressure measurement. So the air embolism is a serious hazard in dialysis. Okay, in any system, air embolism will cause even death. Okay, so air may be sucked due to inadequate flow in the line, and alternate air may be transferred from the dialysis. It is a reason for dialysis equipment includes provision for adequate deaeration of the dialysate. So the venous return flow circuit usually includes bubble trap to diminish the chances of air embolism. And at this point, the venous the pressure measurement is measured. Develop blood in the venous return bubble trap may be monitored with photoelectric cell. Some of the many use ultrasound methods to detect the presence of because when this air bubble, that will result in for a difference in the induced light through photoelectric cell, or that will also, when there is an air bubble, there is an also the ultrasound system can also provide a differentiable, or can resolute a bubble and a normal flowing liquid. Okay, and a pairing pump for pumping out the anticoagulant into the blood to avoid clotting. Blood pressure monitoring system, microcontroller system to synchronize all the operations in the system. And finally, the data interfaces. There are also failed circuitry, cleaning systems, etc. So until this point, you should be in a position to write about the full details. You should be in a position to write about the hemodialysis machine. Okay, so yeah, that's it. So for this this might be even asked in a bigger question, so you should write full details right from the hemodialysis machine start to various systems available, various block diagrams, so that it gives the reader a clear understanding that you have understood the concept of hemodialysis machine. Okay, thank you.